Good day, viewers. You are welcome. So today we have these interesting functional equations where we have f of x plus 1 equals x squared plus 5x plus 6. I want to find f of x here. So for this one, x is increasing by 1 and y this is not. So I want to see the equivalent quadratic equations that we have here. So what to do first here is we have to factorize this thing out, as we have this as f of x plus 1 equals, so when we have x squared, so which is the equation, plus 5x plus 6, and suppose we factor this out, we have f of x plus 1 equals, we consider this as the middle term and we consider this is the sum and y this is the product. So we are looking for two numbers. When we multiply it, we are going to get 6, and when we add it, we get 5. So for the first one, we consider 3 plus 2. So 3 plus 2 equals 5, and 3 multiplied by 2, this equals 6. So actually this is work, so we don't need to stress ourselves again. So we go with this. That is, for this one we have x to the power of 2 plus, so here becomes 3 plus 2 multiplied by x plus 3 multiplied by 2. Then we have f of x plus 1 equals, when we open this one out, we have x to the power of 2 plus 3 multiplied by x, we get 3x, plus 2 multiplied by x, that is 2x, plus here is 3 multiplied by 2. So then let's try to group this. We have to group this one out, and we also group this, which is f of x plus 1 equals x to the power 2 plus 3x, this is in bracket, plus open bracket 2x plus 3 multiplied by 2. So I'm trying to show you step-by-step way of factorizing this quadratic equation. So here we have f of x plus 1 equals, so what is common to this is x. By taking it out, we have x into bracket of, when we divide this one by x, we get x, plus by dividing this one by x, we get 3, plus also what is common to this one is 2. We have 2 here and we have 2 here. We factor it out, then in the bracket we are left with x plus 3. So on arriving to this stage, in this parenthesis we have x plus 3, x plus 3. So we take 1 and then we combine their coefficients together. So here becomes f of x plus 1 equals x plus 2 in bracket, open bracket, x plus 3. And this is a complete factorization of the quadratic above. So there are two factors, which is x plus 2 and x plus 3. But the question here is, in this we have a domain called x plus 1. So our domain is x plus 1, but here there is nothing looking similar to this domain, and we have to make it equal. So to do that, we are going to use what we call form manipulation method, as we make sure we express this thing in this domain. So for the first one, we have x plus 1. So we'll put this in parentheses for this first bracket, and what is missing is plus 1. And we close this. So similarly with this one, since what we need is x plus 1, so we write it as x plus 1 and we add 2 because that is what is missing. So after getting this, and we have this domain here, so what to do next is we have to replace this x plus 1. So by replacing x plus 1, so when we replace it with x, so that is, anywhere we see x plus 1, we write x instead. Therefore, f of x equals For every x plus 1, we change it to x. So plus this one in bracket, open bracket, while this one is x plus 2. So here is the complete factorization of this, as we have only f of x. So therefore, let's try to open this one out. We have f of x equals x multiplied by x, that gives us x squared, plus x multiplied by 2, we get 2x plus 1 times x, that is x, plus 1 multiplied by 2, we get 2. So here we have f of x equals x squared plus 2x plus x, that is 3x plus 2. So here is another quadratic functions for f of x, as what we have above is f of x plus 1. So here is the result that satisfied this problem using form manipulation method. So there's another way of solving this, and if you know it, we can drop it in the comment box. But this is the best way of solving this using form manipulations. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share and subscribe, and turn on the notification bell for more videos. See you in the next class. Never stop learning. Bye bye.